the last type of loops that we will cover is the for loop. And the for loop reads as follows. For a specific number of times, all right, so for a specific number of times, I would like to repeat something, all right, so this is how it reads. If you remember the while loop, we said, while the condition is satisfied, keep doing this. For the for loop, it's for this condition or for this number of times, do this. The for loop structure seems to be more complicated, but actually once you understand it, you will understand how neat the for loop is. The for loop has the keyword for, as you can see here. So let me the pen, and then we have the for loop, the for keyword here. And then for the for keyword, it's followed by parentheses, which should be there. They are important. Then we have the initialization section, we have the test section, the update section, and all of these are separated by semicolon. So that's the syntax. You have to follow this syntax. Then between the parentheses, the curly braces, then you have the statements to be executed. So here in the initialization section, what happens is that you try to initialize a counter. If you remember in the while loop, we had int I is equal to 0, and then while I is less than 100, keep doing this. You remember that example of calculating the area of the rectangles? That's basically the same thing. We are initializing our counter here. Then the test is basically the condition. That's the condition that will keep the for loop going. All right, and usually it involves the counter that you initialized in the initialization section. So we are going to discuss this one more. Then the update is the part where you update the counters that you initialized here. So if you remember again, for the while loop, int I is equal to 0, while I is less than 100, and then at the end we said to make it not infinite loop, we have to increment I by saying I++. That process of incrementing I is called the update. And then the statements, it could be any statements you have. Now, the for loop is a pre-test loop. All right, and to understand this further, I will show you an example and I will explain to you why it's a pretest. So here, this is the flow chart of a for loop. So you have a Boolean expression, as long as it's true. Perform statements, update, and then go back. All right, so it looks very similar to the while loop. So let's go and try to analyze the different sections of the for loop. So here, this is a very simple structure example of a for loop. It has an initialization of int I is equal to 5. So here I'm initializing I by declaring it first as an integer, and then I is less than 10 is my condition. So as long as I is less than 10, keep going, and the update is going to be I++, and then I have number of statements. Now, one thing you need to keep in mind is that this section, the initialization section, is actually optional. You don't have to have it. All right, and that's very interesting. You don't have to have the initialization section, and I will talk more about this when I have more freedom writing the code in BlueJ. You will see a lot of examples, and I will point these out. All right. Now, even though it's optional, usually you have it. Usually you include it, and I have never seen a for loop that doesn't have an initialization section. That's something to keep in mind. The initialized counter is usually the one that you're going to use to test or in the test section, which is I less than 10, right? So if you have a counter here, why not use it here to control the for loop, right? So that's the I, the same you initialized here. This is the I you are using here, and you are using it for the test. The initialization section can initialize multiple variables, and that's something that we will see again later on. You could include multiple variables here. It doesn't have to be just one. And variables declared in the section have the scope only for the for loop. This is very important. This I here, if I try to go here and say system.out.println and print I, something like this, I would get an error. It's not going to work. It will tell me I have no idea what I is. Because I was declared inside the for loop, it has the scope of the for loop. That's it. Done. All right. So that's something to keep in mind for the for loop. All right, the second part that we want to cover is the update expression here. All right, the condition, we have covered conditions before. We have seen it multiple times. So the update section is the interesting part, the new part. The update expression is usually used to increment or decrement. So basically you want to do something with the counter here that eventually gets I to be 10, which is not less than 10, and this way you exit the for loop, similar to the condition in the while loop. The update section for the for loop executes last in the loop, and we will understand why or how. The update section may update multiple variables, similar to initializing multiple variables. You could update multiple variables, and each variable updated is executed as if it were on a line by itself. And in this case here, avoid updating in the body, and again, examples on BlueJ will explain this further. Now, let me go back and show you a for loop and discuss a couple of things related to how it works. Why a for loop is a pre-test. What do you mean by the update section executes last in the loop? All right. All of this will be more clear in an example here that we will have. So let me choose a different color. I hope that worked. So here, this is again the same example that we have. Here is the initialization. Here is I less than 10, the condition, increment or update, and then here are the statements. All right, let's say the statements is basically just an I or system without the print line of I, something like this. All right, so if we do check here how this is going to work, let's trace it. So I will have my I here, all right, and I will have my output here, all right. So let's see what is really going to happen. So the first thing that is going, I'm trying to change the color, but it's not working, so I'm not sure why. So here, the first thing that we will do is that the first thing to be executed is this section. So here, initializing I, that is number 1 to be executed. So I is going to initialize as 5. This is the first thing to be executed. Now, the second thing to be executed is to check whether I is less than 10 or not. So this is the second thing that will be executed in a for loop. Then the third thing to be executed is going to be the statements. So the body of the for loop is going to be the third thing to be executed. So in this case, printing I, which is going to print 5 in this case. All right, the last thing, as we have seen in the slides, to be executed is the increment process. All right, so this is the number 4. Now, since it's a loop, it goes back to step number 2. So this here executes first thing for 1 time, done. Then 2 checks the condition, execute the statements, go back and check and update. That's why update is the last to be executed. Then go back here, check, print, update, and keep doing this. And as you can see here, there is a loop, and that is the for loop. All right, so that is basically the for loop. So here after 5, that part, number 4, is part of the loop. That's one single run of the for loop is going to increment I naturally. All right, then we check, is 6 less than 10? Yes. Then print, which is 6. Then go and, as part of it, increment. All right, so notice here that what I'm trying to say is initialize I, that's the first step, and I equal to 5. Printing 5 and incrementing 6, that is a single step. That is step 1. Then printing 6 and incrementing to 7, that is step 2. All right, then 7 is less than 10, yes, print 7, update, yes, 8 is less than 10, print 8, update, print 9, update. Is 10 less than 10? No, then do not execute. So once 10 is not less than 10, in this case, you exit for loop and continue. So this is how the for loop works. And this is very, very important to understand the sequence, and that this part is executed one time, this part is the cycle, and so on. So I hope that that really explains how the for loop works. So let's go back and try to have a look at other things related to the for loop. For example, here the code for the for loop. So here we have for loop, and what I'm trying to do is to do exactly the same thing as the while loop. You remember the while loop with calculating the 100 areas for the 100 rectangle? That's int I is equal to 0 while I is less than 100. Do this, increment I by 1. And this is the while loop. And if we want to try to do this using for loop, this is what we get. So here we have for int I is equal to 0, initialization. My condition is that I is less than 100. My increment is I plus plus. And then in this case here, I prompt, store, and then calculate area, print area, go back, increment, check, do that, and so on. All right, so here it's very important to see how the two are mapped together. So for example here, you had int I is equal to 0, while I is less than 100. Then you execute something, and then you say I plus plus, and that's the while loop. Now you go back here. Now what is the equivalent for loop? It would be for int I is equal to 0, I is less than 100, I plus plus, execute statements. So you see here, all the components of the while loop are mapped to the header of the for loop. Can you see that? The initialization is here, the condition is here, the increment is here. So that is a mapping of how you can rearrange the while loop into a for loop this way. And that's a question I'm going to ask you. How can you go from here to here? How can you go from here to here? Now, what does that mean? Why do we have two loops? The thing is, the while loop is very powerful to the point that doing this looks messy, right? But there are a couple of things that while loop does in a simple way as compared to the for loop. Now, what does that mean? Notice here that the for loop, it's controlled by these values. I is equal to 0, I is less than 100, I plus plus. That's how any for loop should work. You don't have an option. All right, it has to be initialized value, condition, and update. Now, you could mimic this behavior using a while loop, even though it looks messy, right? Now, there are things that while loop does naturally that for loop doesn't, because while loop can check any Boolean condition. All right. So in this case here, for example, I could say while cup not full, assuming that's a Boolean field. All right. This pass. All right. Now that you cannot simply do in the for loop. All right. So that's why the while loop is a little bit messy here, because it's actually created to do more things. All right. So the while loop can deal with Boolean expressions, with a flag, and using this you can do something, take an action, keep dispensing coffee as long as the cup is not full. Now here in the for loop, you have to say for 16 ounces, keep dispensing. All right. So if you have a sensor that is detecting whether the cup is full or not, while loop will work with you for loop is going to overfill that cup. All right. So that is something you can think of as you work and decide whether to use while loop or for loop, and that will come naturally as you exercise and solve more problems. It will just become natural to you to decide which loop to use. So that's the for loop. Now let's go back to the slides and try to cover a couple of other special cases, as we said. So here, as we said, a for loop can initialize multiple counters. So here, I is equal to 5, I is equal to 0, j is equal to 0. All of them has to be integers. In this case, if you define one of them as integer, in general, the counter should be an integer. All right, even though you could define it as a double, but it makes more sense to define a counter as an integer because your step, the increment, is usually lower. You could actually increment multiple, like you could increment by 2 if you want to. All right, so that's completely up to you. The update doesn't have to be plus plus. It doesn't have to be an increment by 1. It could be increment by 100 if you want. The other thing is that, in fact, every single part of a for loop is optional. However, if you decide not to use any of these parts, you still have to put that structure there, parentheses with 2 semicolons. Otherwise, you will get a syntax error. So that's how a for loop should be written. Now, if you do not specify, if you do not initialize, check condition, and update, Java is going to assume that you don't care about all of these, and it's going to run infinitely. All right. So this is how you get an infinite loop using an infinite loop using the for loop, and also that's basically checking that that condition is always true. It's equivalent to saying while true, do something. And the while runs with the true, and if it's true, it just keeps infinitely running. Or while I is less than 5, and actually before I is equal to 0, and we have no increment here. So that's again true, while true, it's always true. So that's the idea. One thing I would like to show here in the code, jump back to code, and I would like to show something related to the for loop. So I'm going to delete this complex for loop and show you a simpler one. So here, if so let's say 4 into I is equal to 0, I is less than or equal or less than 5, I plus equal to 2, for example. All right, something like this. And this is my for loop, and then I have my curly braces. In this case here, I can, in this case, system.out.println, and I'm going to print these numbers. And that is going to print 0. But I forgot to print something. Let me print R. So 0, 2, 4. Right? We're starting from 0, and we are incrementing by 2. And in this case here, we have we are printing up to 5. So 0, then 2, and then 4, and then the next one would be 6, which is not less than 5, and that's why it's going to stop, right? So that's actually the last value in I is going to be 6, which is not less than 5, and that's why it's not going to exclude. That's a good exercise. So here, what I want to do here is that, now what if I try and say, I'm going to print I outside, so I can just copy and paste this one here. Notice here, when I compile, I'm going to get a compile time error. Cannot find simple variable I. You cannot find I because I is defined in the initialization section, and that's why its scope is just the for loop. All right, so that's an issue. Now, to overcome this problem, if you want to have a scope outside, just simply declare it outside. So I could do something like this. All right, so something like this would also work. Compile. I'm going to print here, as we said, this is printed from inside, right? So we see it. Here we go. Run, compile, run. All right. So here, 0 to 4, it comes from the loop, and then space, and then the last value of I is going to be the 6, because 6 is greater than 5, it's not going to run, and it skips, and that's what is broken. So that's what I was talking about. So that's the thing, you could actually initialize it outside. In fact, you could not just declare it outside, you could even initialize it outside. Here we go. You remember we said that initialization section is optional, and that's why you could do it this way, and it's going to step 2. Also, since we said that section is also optional, you could do the increment similar to the while loop. All right, so that would also work. However, the nice thing about for loop, the advantage of for loop, is that it's very neat, that it puts all of these components into the header. So it doesn't make sense to go back and try to mimic the while loop structure in this way, right? Then now you are going to have that messy structure. What if you forget to increment? What if you initialize it wrong? So I would say avoid doing this, even though you can, as you can see here. I'm just showing you, but try to avoid doing this, and try to keep everything nicely and neat here inside the for loop